MacMaths, let's do some maths today. Okay guys, we're back. We're looking at 10.3 in the textbook, and at AS level, the book, the Trigonometry chapter, introduces you to two identities, and we're going to look at those two identities today. It's going to be a shorter lesson. I'm just going to go through the two identities, prove them for you. It is in the textbook. It's easier when someone is showing you. Okay, so I'm going to go through those two, and I'm going to go through the examples in the textbook. Now, I don't normally do that, but you are going to find these difficult the first time that you do them, because it's not like anything else you've seen before, you know, even at GCSE. Okay, so on to the two identities. Ready for this, I've drawn the ratios out that you know from GCSE, and I've drawn a right angle triangle. What I'm going to do for this is I'm going to label the hypotenuse of this one unit, just to make it easy. I could choose any number, but I'm going to go with 1. This is the horizontal, like the x-axis, so I might as well call that x, and the vertical I'll call it y. So I've labelled up my triangle ready for this, and then if I pick the first identity, the first ratio here, sine theta is equal to opposite over hypotenuse. So on this triangle, I've got my baked bean in there ready. The sine of theta is equal to the opposite side, which is y, divided by the hypotenuse. The hypotenuse is 1, so y over 1. So sine theta is equal to y over 1, and of course y divided by 1 is just y, so we can just call sine theta y. Likewise, if we look at this ratio, cos theta is adjacent over hypotenuse, so the cos theta, of course, is x over 1, which is just x. So now I can replace the y with sine theta. So we can just put that there. Okay, and I can replace the x with cos theta, and that happens because I've made life very convenient for myself. It only happens because I called this 1. Okay, if I called it a bigger number, okay, I'd have a number involved here. If I called it 2, there'd be a 2 cos theta and 2 sine theta, because we would have had to move that 2 up. It would have been fine also. Okay, so now we've got that in place, let's just get my rubber, which I can't find. Oh, there it is, my little cloth, little J cloth, rub those out. Let's have a look at the two identities. Okay, so the first one is from Pythagoras. You know that a squared plus b squared equals c squared for a right angle triangle, which is what we've got. So this squared plus that squared must be equal to 1, and that is our first identity. Okay, we usually, for some reason, you see it written down as the sine first. I don't know why that is. So I'm going to go sine squared theta plus cos squared theta is equivalent to 1. You see the 3 little lines, and there's our first identity that you need to learn off by heart and get used to seeing that. Okay. First of all, you notice that I've put the little 2 there, the little squared there, and not after that. That's so you don't thinking that it's the angle squared. You know, if we write down the sine of 30 degrees, you know, and that's squared. Well, the sine of 30 degrees, as you know, is a half. So that is a half squared, which is a quarter. Okay? But if you just saw it like that, you might think that it's the sine of 900 that is a quarter. You know, 30 squared is 900. Okay, it doesn't mean that. It means whatever the sine of 30 is squared. So that's why we put the little 2 there, so that you don't think it's the angle that's squared. As much as you see this, just get used to rearranging that, because probably more often than you see it in this form, if we simply take sine squared off both sides, okay, take sine squared off this side, we're left with cos squared theta. So cos squared theta is equal to 1 minus sine squared theta. So look out for that, and look out for its other cousin, which is the sine squared theta is 1 minus cos squared theta. Okay, we take cos squared off both sides. Let's be consistent, put the little 3 arrows in. Okay, so that's our first identity, and it's the 2 other ways of writing it. And very simply, we're going down to this one here, tan theta is opposite over adjacent, so tan theta is equivalent to opposite sine theta over cos theta. Get them the right way around, please. Remember that. Okay, got helped me out and many a scrape, that one. It's kind of come in very handy. Okay, so those are our two identities. No, actually, I'll show you. Like I say, I don't normally do this, but the examples in the book are these three. And if you look at this first one here, they've decided to put in they want you to simplify these three expressions, and they've put sine squared 3 theta plus cos squared 3 theta. Okay, you can probably see that it's just this one here. Okay, the angle here theta, well, they've just changed the angle for 3 theta. If you think about it, if you dig a hole and you dig the hole twice as big, you'd still call it a hole, wouldn't you? So 2 times a hole is still a hole. And so in this particular chapter, they'll get you used to, you'll see them use theta, but you'll also see them use 2 theta and 3 theta and half a theta and so on. These are just an angle, okay? So they're just getting you used to seeing those and using them without putting too much thought into it. But they are going to come in, there's a reason for that, and you're going to find that reason out when we do A2, because some of these are included in the identities that you're going to learn next year. Okay, so it's just getting you used to those. All right, so going back to this one, okay, sine squared of an angle plus cos squared of the same angle, okay, is equal to 1. So all that simplifies to 1. Simple as that. 5 minus 5 sine squared theta, well, we can factorise that, can't we? So we can take out 5, so we've got 1 minus sine squared theta. Okay, and you can see there, well, there you go, 1 minus sine squared theta is cos squared theta. So that is cos squared theta. So it's 5 cos squared theta. Simple. And this last one here, we've got to simplify sine 2 theta. So it's just sine of an angle. 1 minus sine squared of an angle. Well, 1 minus sine squared of an angle is cos squared of that angle. So that underneath the square root, of course, can be written as cos squared 2 theta. It's the same as that. It's just replacing this bit with that bit there. Okay, and just sticking with that bottom for a minute. Okay, it's cos squared 2 theta square rooted is just cos 2 theta. And on the top, of course, we had sine 2 theta. Let's stick it in now. Sine 2 theta, sine 2 theta. Okay, and sine 2 theta over cos 2 theta, of course, is tan 2 theta, because that's the other identity. Sine over cos of an angle is tan. Sine over cos of an angle is tan. So tan 2 theta. Okay, did those fairly quick. Don't do them as quick as me. I'm a trained professional. Okay. Let's just have a look at these ones here. Okay. This one here, okay, looks a little bit of a mouthful. This time we've got to prove that all of this is equal to that. Can I just remind you, from GCSE, you are used to seeing this sort of equation, a squared minus b squared. And you know that that factorises, if you remember from GCSE, that's one of those special cases that factorises to x plus b, a plus b, a minus b, all the time. Okay, so you might have seen it as x squared minus 16, mightn't you? And you'd put the answer down as x plus 4, x minus 4, okay? And that's what this is here. Cos to the power of 4 theta is actually cos squared theta squared minus sine squared theta squared. So it's just like a squared minus b squared. So it's a plus b times a minus b. In other words, it simplifies to cos squared theta plus sine squared theta times cos squared theta minus sine squared theta. But cos squared theta plus sine squared theta is equal to 1, so all of this is equal to 1. Okay, so we're just left with, that is all 1. One lot of that is just cos squared theta minus sine squared theta all over cos squared theta, and all of that divided by cos squared. You know me, I like to write it out. Cos squared theta over cos squared theta minus sine squared theta over cos squared theta and cos divided by cos squared divided by cos squared is 1, minus sine squared over cos squared, there it is, sine over cos, okay, is tan. So sine squared over cos squared is tan squared theta, which is that one there. Okay. Look at how they do it in the book for this. They just simply put the cos, they square it and put cos in there, but don't do it that way. Okay, do it my way. My way is always better. Okay, this is a really nice way of doing these sorts of questions. Draw your little triangle. We always love a diagram, don't we? Okay, us mathematicians. Let's put our angle in, little right angle triangle there. The cos of theta, I'm ignoring that sign for a minute, okay, as I do when I'm doing the cast wheel. The cos of that angle there is 3/5. And remember, the cos is adjacent over hypotenuse. So the adjacent is 3 and the hypotenuse is 5. So to complete our triangle using Pythagoras, you can see this is the 3, 4, 5 triangle. There you go, so 3, 4, 5. Okay, and now it says find the sine of the angle. Okay, so sine theta is equal to, now sine is opposite over hypotenuse, so 4/5. If it asked for the tan, it doesn't, but if it asked for the tan, you know, that's opposite over adjacent, so that would be 4/3. Okay, there's a bit more to the question than this, and there's a whole section in the next exercise, 10C, that are this sort of question. They're all done like this. Do this little diagram, do them this way. Okay, and if we draw the cast wheel, let's have a look at this one with the cast wheel. Okay, 0, 90, 180, 270, 360, C, A, S, T. There's our cast wheel. Okay, and it says that cos theta, so this angle here, there's theta, the acute angle, this angle is actually a reflex angle. So it's not here, it's the same angle, okay, but it's a reflex angle. So if it's a reflex, it's between, get me blue, in this region, isn't it? It's between 180 and 360. That's what a reflex angle is, okay? But you can see the minus is the telltale sign here, okay? If it was in this region, if it was 270 to 360, it would be positive for cos. So you wouldn't have a minus there. So it must be in this region. So actually this angle, it's that angle, but it's in this region here, okay? This is the angle wherever it is, okay, that gives you 3/5 or minus 3/5 in this case, okay? So that's the angle there. And of course, in this region, okay, that is negative for sine, because sine is positive in the all, and it's positive in the sine region, but it's not positive between 180 and 270. So we've got to change this now, okay? This 4/5 is actually minus 4/5. Okay, so there we go. That's the exact value. If cos theta is minus 3/5 and theta is a reflex angle, then sine theta by Pythagoras is 4/5. It is also minus because the minus and this information here tells us which quadrant it's in, okay? And it's an angle in this one here. If the question had said find the exact value or the value of tan theta, we would have done 4/3. We would have looked where the angle is. Yeah, it's in tan, so it's positive. So that is a plus 4/3. It can just stay as that. Okay. I will do another, video, like I say, of the exercise. I'll go through each question. It'll be a longer one, you don't need to watch it all, but just the bits on the questions that you get stuck, you can fast forward through it and just pause and have a go at the questions and then see me explain them. Okay, but I'll go through most of those questions in that next exercise because you will find some of those quite tricky. Okay, thank you. That's over and out from me.